All right, welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. We are still developing a MachOCodeGen reader and CodeGen. Not yet, well, they're just a reader, yeah. Okay, so what do we want? We want... Oh, right. We hit this assert here, right. Because here we have a radar update and here we have subsystem interface init. No. Yes. Base entries, subsystem interface init, post process reset, init subsystem post process. Is pure virtual true? Yeah, I mean, to me it looks like it should be subsystem interface. Then why? What do we do here? Base class, also subsystem interface. Okay, that's correct. But here we have radar update. Entry update. Radar class vtable entries init reset update init reset update init reset update init reset update init reset. Okay, we need to compare this vtable. We have let's open this in the watch. Yeah, entries. Let's make this large. Oh, Jesus Christ. There we go. Okay, so init reset update draw init reset update. But here's a post process load, but it's not here. Post process load. It is not here. What does that mean? Which base class is this now? 1. So the base class index 1. What is the base class? It has an offset. Okay, I'm not sure what this means. Why? I would have expected that here would be... What is this, a pure virtual? No, it's not a pure virtual. But why is there no... Why is there no post-process load function here? Init post-process load reset update draw. Why init reset update? Update. Init. Base class. Subsystem interface. Man, why is this so hard to implement? I can't believe it. I can't believe it. I don't understand the problem now. Okay, so the first question I have is why is this not set to is overrides? I would have expected that this would happen. What is the base class? Let's radar. Yeah, let's put a breakpoint for this one. Copy value. If class type dot name is radar, then int a equals 0. Put a breakpoint. Let's step through it and see exactly what happens. Yeah. Good, there we are. Okay, so the first base class is here. It has a vtable, one vtable with 3 entries, and they are snapshot pure virtual function. Yeah, and they already have names. Good. So what do? Regular count 3. And here we have 0, 0, CSC, that looks good. Yep. It's override, yeah. Okay, next. Is override true? Yep. And what do we have now? Okay, now we have radar, load post process, and snapshot load post process. Okay, so this refers to this. Okay. Yeah. Oh, it's override. Good. Okay, now we reach the destructors. No, we don't. Because we're done with this one vtable. New virtual function count is 4. Why? 4. Because we are missing some for some reason. Yeah. Let's go back here. So primary vtable count And the base classes, base class type snapshot, this one has 3 regular. There we go. And this one has, I think, 7, right? 7, yeah. With probably 2 destructors, yeah, and 5, 8, 8. Regular counts. What? What? 2, 8, 2, 12. 2, 8, 2, 12. Assert. 2, 12. Vtable count. So let's go to watch this. Vtables 14 and 7, that's 21. Minus 2. So we look at 19. Huh? Well, what is happening here? Vtable count. Why is this 2 and 12? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Vtables. Huh? Oh. What? Okay, what I find interesting is that both base classes have radar. Init reset updates. Init reset updates. Post process load. Okay, so here we have 14, 2 and 12, 2 and 12. Two and 8, 2 and 8, 2 and 12, 2 and 8, 2 and 8. This vtable is the first one. Why 8? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 plus 2. 12. 12, this is correct. And this is 2 and 8. Base. We should look at... We should not look at... Okay, here the secondary vtable, that one looks better. That one looks better. Shit. Yeah. Index. Maybe. Offset. Shit. I don't understand. I don't understand. Why is this so different than the other cases we had? That makes no sense. It's unbelievable. Why is this suddenly... Why is this suddenly... Oh boy. Why is this and this function, why are these two not in here? That's what I don't understand. Oh Jesus, why? Why is it always so random? Oh boy, it's so bad. It's so bad. There's no rule in here. It's just random. Why is this random? Why is this function not in here? But it is in other cases. Like it is here. See? Here. It's in there. But here, it only shows the radar thingies, but not this. Why? Why? Why is that? Maybe because maybe the pure virtual function, the destructor being not here at the top, maybe that changes something. That could be. Yeah. Yeah, maybe. That would be my only hint here. Yeah. Well, what we could do is we could cross-reference this with cross-reference. So I suspect we have to cross-reference it with the secondary vtables to really make sure to capture the right sizes. Yeah. That sucks. Shit. Makes it so complicated. So here the radar is here. Radar is Boy. It's quite remarkable that this doesn't work. So the radar destructor is now based off a base class that is not at offset 0. I think that is the main difference here. And maybe that's why the vtable looks so different than the others. And it's sad because it makes the whole exercise so much more complicated. I don't understand why it is like this. Why? I mean, if they change the conditions like so drastically, why would anyone do that? It's typically you want to keep it super simple. Super simple, but maybe there's some technical reason. I don't think that this is just at random and some bug. There probably is a reason, but maybe not. I find it extremely weird. It would be so simple if the vtable here would simply contain this and this. Shit. Boy. That is remarkable. It really is remarkable. Come on. You have no idea. Oh boy. Well, at least the secondary vtable is always a good match. That's the good news. So there is some way to do this, but it's just so convoluted, right? It's so complicated. But what we can do, I mean, for the overrides, we can. I mean, just for the replacements, for the substitution of, yeah, for the completion of the pure virtual function names, the secondary, using the secondary vtable should be good, but we still would need here in the primary vtable, we would still like to make a statement if something is an override, right? Or not. I mean, what we could also do is we could say here we could say here that when the base offset we could always say when we use the first base class, we use the first vtable. When we use the second base class, we use the second vtable. Right? We could do that. Yeah. But then we wouldn't set this override and this implicit flag on the primary vtable. Oh. But maybe Maybe. Yeah. Maybe we just process the primary vtable just up to the point where the first base class ends, and then we just stop there, and then we just do and then we use the other vtables, the secondary ones. We could do that. Yeah. Maybe that's the way to go. So here, this is first. Well, we stopped the debugging, did we? Can't see it anymore, but yeah, what we can do is we just say, yeah, we stop processing it. Yeah. Okay. Maybe it's a good idea. Yeah. So that means but hold on. Yeah, no, I think that's fine. Yeah. Yeah. I think this might work. Yeah. This might work. Yeah, I think we are onto something. Yeah. So how do we write this then? Base vtable. Oh boy. Okay, how about we delete this here? We delete this. And we do the following. We create a new copy of this, yeah? And we comment out this old one. And we create another new function. Yeah? How about that? Let's put it at the bottom. Yeah. Oh boy. Okay. Let's try a new one. So then we will, let's see, we will we don't do this. Base class counts. Base class. Good. So base class index. Okay, base class. We should have an assert for class type dot base classes dot size should be identical to class type dot vtables dot size, right? Should be the same. No, that's not true. That's not true. You can have a class with a vtable that creates a. But actually, hold on. No, it's correct here because here at the top we checked that we have base classes and we have vtables. And if that's the case, then we expect that those are match, I think. Yeah. So I think this is true always. Yeah. Okay, and then we say here vtable. Let's take this guy. Let's remove this. We remove all these guys here. We take this vtable, and we take base class index. And then vtable. Okay, and then we put the vtable here. And the base vtable, we use the same here. And then we use base vtable count. Base vtable. We use let's just use here combined count. Base vtable combined count. Okay, and then we use const un16t vtable count, and that is vtable dot combined count. Okay, vtable count. We expect assert that vtable count is larger or equal base vtable count. Right? Let me stop the debugging here. vtable count. Well, actually, if base class index assert base class index is not 0 or this, base class index is 0 or this, right? So that means if base class index is 0, then this must be true. If the base class index is not 0, then this must be true. Yeah. Okay. Then here we do vtable count. Let's do vtable index. Vtable index. There we go. And then we use base vtable count. Base vtable count, yeah. Okay, entry, vtable index, vtable index. Now, I think we don't need this here anymore, other than for checking, for asserting. Yeah, for asserting we can use it. Assert. Do we use it for anything? No. So I guess we can say, yeah, is detour equals space is detour. Let's say maybe unused, Okay, and then I think we can remove this here. Don't need that. Direct base class is this. Direct. What is this initialized with? 0xff. Direct base class. Direct base class. Yeah. I'm not sure if we need this then. Direct base class that this virtual function belongs to. Direct base class. Because it's kind of useless information here, isn't it? Let's remove it for now. Yeah. It seems useless. Okay. And then we remove this here at the bottom. Okay, so now it would also visit the, what is this? Okay, we don't need this here anymore. Let's remove this. Let's remove all of this. Okay, it's much shorter now, which I guess is good. Let's put a breakpoint here. Okay, so now it will only use the primary vtable to check with the first base class, and then the secondary vtable with the second base class, and so on. Yeah. That means that means that we don't use the part of the primary vtable that contains entries of the secondary vtables. So from entries that refer to base classes with offset not 0. I don't know if that's a problem. Maybe it's not a problem if we just don't, if we just use the vtables. I don't know, it would be nice to just use a primary vtable, but it makes everything so complicated. The primary vtable, because the order is so chaotic. That's the problem. It's so chaotic. Because you have the new, we need to use it because of the new thingies in there. We cannot just stop. We cannot just stop it at the secondaries. Oh, Jesus Christ. Because the first... Okay, let's test anyway. Let's test this so far. I mean, if we can populate like with the secondary vtables as well, I think that's good. It gives more confidence and things, so that's good. Like this assert here, for example, right? Let's see. We have an assert. Oh boy. 1, 2, 1, 1. Oh. Base vtables. Sample sounds. Base classes 2. Right, so right, base class. Yeah, what if one of the base classes does not have a vtable? Let's do base class count. Base class count. How about we do base classes, vtables? Huh? Well, base classes don't have to match vtables. When I think about it again, because you can have a base class that doesn't have virtual functions, right? Yeah. I think this assert actually makes no sense. Let's remove it again. And here I would say what we do is base class count, base class. Shit. We need to how about we do vtables, vtable, vtable, and then vtable dot offset, and then class type dot get base class m classes with this offset. Yeah. And base class, base class, base class. And if we have a base class, if we don't have a if base class is null pointer, which seems to be possible, then we continue. Okay, base class, and then base, and here we do base class, base class, there we go, class index, if vtable's empty, base vtable. So we already have this here, base vtable, I think we are looking at 0, base vtable 0, vtable count, if vtable dot m offset is not 0 or vtable offset 0. Okay, let's try this. Yeah. Let's take this guy here. Maybe move it up here for testing. Tests, tests. Okay. It's detour, it's detour. Okay, what do we have here? Entry. Idle. 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 Huh? It's detour, it's detour. Fast. Huh? I don't get it. They both don't look like destructors. Why is this labeled as destructor? Huh? C sample sound 3D idle. Why is this recognized as a destructor? Huh? Two. Maybe unused. Is detour. True. Huh? Hey, my gosh. This is so hard. Hey. This vtable bullshit is so hard. I don't understand why is this not true. Like, this clearly doesn't look like a destructor. Right? Function index. Thunk index. Maybe because probably it has the wrong name assigned. That could be. Maybe. Idle. This looks good to me. Sample sounds. Sample sounds 3D is class type. Sample sounds 3D. Yeah, this looks okay to me. Why is this wrong? Is detour is true? Is detour is true? Yeah. C sample sounds 3D idle. Is detour true? It's true. I don't understand why this is true. Functions, entry. That's strange. 3. Entry 3. 3. Entry. C sample sound idle. I don't understand why this is classified as a. I mean, what's weird is that this is. It's a. It's weird that the function index is not proper. Ah, thunk index is 0. Thunk index 0. Okay. Let me see mthunks, please. Mthunks, the first one. But that's not... Is detour equals true? Huh? They're all true. What? What? Okay, that is unexpected. M is detour true. M is detour. Oh. I think this needs to be is not std string endpos. There we go. I suspect now it's right. Yeah. Oh boy. That's a stupid mistake. Okay, let's try it again. Oh, finally, we didn't hit a third. That's good. Okay, what do we have here? So, I think we can actually remove this one, yeah? Okay, so we have vtable, yeah, 14. Good, so base class, yeah. Base class snapshots. Okay, so vtable, 3, 14, 3. So offset is 0, so it can be larger or equal 3. And this condition doesn't need to be met. Yeah, good. So then 3 entry is this snapshot. Is detour false? False. Yeah, that's good. Pure virtual false. mname radar class is override. Yeah. Okay, this looks good to me. Assert mname equals, this should be true. Yeah. Okay, good. This looks good. Let's see the next one. So this is that. Okay, another assert true and another one assert true. Yeah. Okay, what do we have now? Now we go in the snapshot, but we don't care about the snapshot. So now we go here. The next vtable. Next vtable is the radar, this one. Yeah. Okay. So base blah blah. Okay. Subsystem interface. Yeah. Okay. Vtable count is 7, 7. 7, 7. So these match. Asserts are passing. Yeah. Entry radar. Okay, so this is a destructor. This assert passes. Is an override. Okay, good. good. Yep. Okay, this looks good. Forwards. Entry. So we have init, and this now looks good. Yeah, okay. Okay, so we are now definitely going through all the primary and secondary vtables. Well, but we skipped the last parts. The last parts of the primary vtable. But we need to do something there still. But I think it's now, there is a chance that now this no longer hits. That we now will have all pure virtuals. There's a chance. Let's say, oh god, we got it on certs. Never mind. What is happening here? Class, what is this? Offset 0. Offset 0. 0. Yeah, I mean, this looks rather innocent. Let's do it once more. But let me remove this stuff here. I think we don't need it before I forget it. Yeah. Okay, let's see. So we have 0. We hit this 4. 4. Base offset 0. Base class. Base classes starts with base offset 4. Okay. So base offset 0. Okay. 0. Base offset 4. 0. 4. Get base class. Offset 0. Offset is 0. vtables 1. Class type m base classes. At offset 4. And we why vtable. So offset 4. Is this correct then? This 4. What class is this? User preferences. Vtable of user preferences. vtable for user preferences. There we go. Good. Offset 0. Type info offset 4. Yeah, okay. Then get base class. Yeah. So if the base offset is 0, base offset 0, 4, 4, 0. Maybe it should be a condition. If base offset is larger than this, yeah. If then call in there. How about we move this also to the side so that these conditions are similar. So if base offset is this, if base offset is larger equal if base offset, yeah, then we just take it. Okay. And if this is larger, if this 0 is larger equal than this, that's large. Yeah. I hope that this is correct. It's hard to understand. I just hope it's correct. Yeah. Let's see. Well, if we figure that we got all pure virtual function names, I think then it wouldn't be bad. Oh no. Unfortunately, it hits more than once. It hits 43. Oh my gosh, it's more than with our first implementation. That's a shame. That's a shame. Here with this implementation, it was 11, and now it's 43. So we perform worse now. Our new version is worse. Why? Why? We do this exact same thing here. It's not pure virtual. This is the same. Why is this less? Well, yeah, less successful. Boah, what did we break here? That's unbelievable. Unbelievable. Base class. Okay, well, at least we didn't hit a assert, right? Well, I guess that's good. Oh boy. So, but then we're still missing something here, but I don't see what that is. Okay, we need to see an example of where it hits here. Oh man, will we ever be able to process all pure virtuals? How hard can it be? How hard can it be? It's absolutely insane. It's insane how hard this is. Object module. What's the problem here? vtable. This looks good. And here we have a pure virtual. Object module. Why? Why? Object module. Object module. Object module. Yeah. Okay. Object module. It is then. Then let's do base class type. If base class type is object module, then we put a breakpoint here. There we go. Let's see what that is. Let's go. So we got the first hit. So we have, what is the top class? Behavior module. Behavior module has this. It also has a pure virtual here. Yeah, that's a problem. Yeah, so what do we have here? 48, 12. 12. Entry. So there's destructors, okay. Both are destructors. Is override. Good. What then? Then again, two destructors, okay. And then we have here a pure virtual and here a pure virtual. Okay. And now what? Now what? Is implicit. Pure virtual. Both are pure virtual. Okay, so this didn't help us. Let's press F5 again. So we have another hit. Again, object module. Okay, what do we have here? We have this vtable. And this one also has a pure virtual here. Yeah, that doesn't help much. Okay, let's check the next one. Another pure virtual here. That is behavior module again. Let's check another vtable. Pure virtual. So this is that the highest class is Thyme module. Thyme module also has here a vtable, and it's also that. Next. Behavior module. What do we have here? Damage module. Damage module also does not implement this function. Then who does? Who does? Collide module. Okay, it looks like no one does. No one does. Yeah, then what? If no one does it. But then why did it work with the other approach we had? Why did it work? The update module or object module. It worked with. So previously we had missing virtuals with upgrade MOOCs and these three, right? But now we have it with object module. When we did it with this one, we didn't have this problem. Why do we have it now? What are we missing? Here we did a different approach, but otherwise similar. I don't get it. What are we doing different now? What is so different that it just breaks? Is it maybe one of these exclusions here? But vtables, base class. Well, if there are no vtables. If the vtable is empty, then there's nothing to do, right? Or am I wrong? Base class. Base class. Vtable empty. Base class. If there are no base classes, then there's nothing to do. If there's no vtables, there's nothing to do. Seems to be right. Hey, Mane, why is this so hard? Why is this so hard? I don't get it. Why is this wrong? Why is there no class that overrides this pure function? What is wrong with this code? Ugh. This is crap. Absolute trash. I don't get it. We got another one. And no matter what we look at here, no matter what we look at, Tables. Well, could it be that maybe this one here fails to return a critical. Let me put a breakpoint in here. Yeah, let's check that real quick. Maybe this one doesn't return properly. Yeah, it could be. Maybe. Yeah. So what do we have? Offset 0. User preferences. Okay, that's fair. We have already established that this one has a base class std map or something like that, right? Okay, what else? We got user preferences again. Why again? How often will this hit? Again. Okay. Again. Again. Always. Texture load task class. There's a base class at offset 4. Base class. Okay. What is it? Class type. Base class. Texture load class. Texture load task class. Texture load task class is already implemented here in Thyme. It doesn't have inheritance here. Parent base class. So what is it? Base offset 4. Class index 1447. 1 m classes 1447. Texture load task list node class. Here it is marked as friend class. What the hell? Friend class. I don't know what to say about the friend class thingy. Yeah. Okay, texture load class. Yeah. Okay. Well, that doesn't look suspicious to me. This looks okay here. Yeah. This looks okay. Yeah, but then why? There must be some stupid reason why we don't get object module. Yeah, why we don't get a hit. That is really, really strange. But there must be some simple explanation for this. Otherwise I can't explain. It's body module, vtables. Holy shit. That's some huge vtable. That's a huge vtable. My gosh. So this function here, this one function, is never overridden. Why not? Why not? Why? Now we do go deep here, no? So if we skip here, then we go into the child of that one, right? Yeah. It's 2 vtables, 1 base class. How's that possible? Vtables. Offset 0, base class. Oh. This one is another base class, right? Yeah, okay. Yeah. That's fine. Yeah. Yeah. Okay, how often does this hit here? 1, 2, 3, 4, 5, 6, 7. Okay, here we have 3. What is that? Firing tracker. Firing tracker is a vtable. There, look, get module name key. That one should delegate down there. No? That definitely has a name. Look at that. So we should be getting it. Hold on. Hold your horses. Let me see. Class type. So here, behavior module. This one doesn't have it right now. Right? Here. Okay, what about the next one? Next higher up. This one, update module. It has it. It has it. Get module name key. Now let's see what happens here. 12. 12, that looks good. Destructor, detour, good. Okay, another destructor. Okay, blah 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 blah. Okay, and now we should be at our. Oh, what's going on here? Huh? Huh? Why is this unknown here? Is pure virtual true? We should have a name, no? Oh, I think I understand, no? Hold on. Here we have update module, and we have is pure virtual. Ah, could it be that the problem here is that this condition here, it only says if this is not pure virtual, but we also need to give it down if we hand it from one pure virtual to another pure virtual down the chain, right? I think that's a problem. Yeah. So we need to say if not, this name is empty. If not mname dot empty, and this is pure virtual. Yeah. Yeah, I think that's a way to go. Let's try that. One, two, three, 4, 5. There we go. Okay. Ta-da. Okay. Da-da. Next. There we go. Okay. Next. There we go. Get module name key. There we go. Yeah. Is implicit. Is implicit. Mname. Behavior module. Behavior module. If not, is pure virtual. If it is a pure virtual, then it is implicit. Yeah. If it is a pure virtual, yeah, it can only be. Yeah. And now we go in here. Superb. The name is empty, and now it assigns a name. There we go. Object module, get module name key. Perfect. Okay. Let's remove this breakpoint. Let's see if we hit this one here. And we do. Oh my gosh. What is it this time? Parameter class. Okay, we have seen this before. Yeah, definition class. We have seen that as well. Call system class. Well, it's 10 now. We improved by 1. We improved by 1. Okay, but why are there still some left? Oh my gosh. Okay, well, it's improvement. We went from 43, previously we had 11, now we have 10. Look at that. It's 10 left. What is parameter class? I mean, it is possible that maybe these things are never overloaded, right? Let me see. What was the name here? Parameter class. Yeah. I mean, maybe they are never implemented. Could be. Let's take this here, parameter class, put a breakpoint here, there we go. Primary vtable, base class. Yeah, I mean, it should hit, right? Should hit. Actually, hold on. We should probably put this. We should put this here, right? So if this doesn't hit, it means that nothing inherits parameter class. It's just a class that sits somewhere, but is never used, right? That could be. Yeah, it's never a base class. It's never a base class by the looks of it. Parameter class. Let me see if that's in Thyme. No. Definition class. No. Cal system class. That's there. That has pure virtuals. Okay, well then that should be used somewhere. Calsys. Cal system. Cal system class. Cal system class. Okay, it's also never. It's never called. Cal system seems to be unused. It's not used in Thyme either. I don't see it being referenced anywhere. Okay. I revised implementation and I now have, how much do we have? Now I have have 10 of 12, 16, 12, 16. Yeah, 10. I revise implementation, and then now I have 10 of this pure virtual functions left unresolved. The remaining 10 appear to be classes that are never implemented. Parameter class, definition class, call system class. Yeah. Okay, but this implementation here, which looks rather simple, it will get us, as far as I can tell, all the pure virtuals. Yeah, but it won't give us all the overrides yet because we skip parts of the primary vtable. So we need to think about that a bit, what we do about that. Because we still need to know which we still need to know which functions are new, right? Which functions are new? Yeah. So I think we need, we need to make some. Yeah, we need to think about this a bit more. Okay, but this already looks promising. It looks really simple here, this code. That's good. If we compare it with what we had before here, this abomination is much more complex. This is also much more complex. And then we had this thing down here. So we had some bigger implementations already. All this code we can remove. Look at that. So we have now this one function here that does a job. That's good. If we just need to add a bit more code to get all the stuff that we need, then that would be fantastic. Yeah. Good. I think I will take a break here then. Yeah, it's been 2 hours almost. Good. I think that was a good session. Yeah, we got almost all pure virtual functions resolved. The last remaining 10 that are left unresolved, to me, looks like these are classes with pure virtual functions that are never actually implemented. So it's just a class is sitting there, but it doesn't do anything, right? And then, yeah, then this is legitimate. Yeah, that's legit. Good. Then, yeah, I will take a break here. I wish you a great day or night. Until next time. Goodbye.